Okay, we're going to look at a type of trigonometry called reduction. And we're going to start off with a sort of general approach because I think it helps us do all the questions. So let's just start off here. Here we have a diagram, and you've got this angle theta, and it's that circle we have with the radius like here. And they say, hey, let's take a look at a reflection about the y-axis. So instead of x and y, we make minus x and y exactly on the other side, but right there. Well, you'd have a triangle here, right? Where you get your trigonometric functions. X over r is cosine, y over r is sine, and y over x is tangent. Well, over here, it's exactly the same triangle, but one thing is changed. X is negative. So when you are at 180 degrees, and oh, look, this is theta, you're actually going in a clockwise direction because it's minus theta. You're going up here. There would be your theta. It's the same angle as this over here, but it's starting from the horizontal and making it negative. And look what happens to the trig functions. While you're in the second quadrant, hey, you know that sine is going to be positive. Y over r. Well, so the sine of 180 minus an angle is really just the sine of the angle. And you could try that with like 30 degrees. The sine of 30 is equal to the sine of 180 minus 30, 150 degrees right there. But the cosine of 180, well, it's going to be negative because x is negative. So the cosine of 180 minus an angle is equal to the negative of the cosine of the angle. So cosine's negative. We knew that in the second quadrant. But the tangent of 180 minus an angle is just the tangent of that angle, but it's negative. Okay, so the sine of 180 minus theta is always the sine of theta. And the cosine of 180 minus theta is the negative of the cosine of theta. And the tangent of 180 minus theta is the negative of the tangent of theta. It actually turns out it doesn't matter how big this angle theta is, this always works. But for picturing this thing, think of theta as an acute angle. Okay, so that's if you're in the second quadrant. What about the third quadrant? Well, if you're down here, if you have this angle theta here, this is the angle of 180 plus theta. But look, if we made negative x and negative y, we'd have exactly the same triangle, exactly the same trigonometric ratios. Only the sign would change. And this theta here, if I bend up here theta, there's 180 plus an angle of theta down there. I like to call this the reference angle. But look, hey, we can go look at each one here now. We're in the third quadrant, and we know sine is negative down there. So the sine of 180 plus an angle, and that puts us into the third quadrant, is the negative of the sine of theta, because sine's negative down there, minus y over r. The cosine of 180 plus is also negative. Cosine is negative in the third quadrant, minus x over r, so it's minus cos theta. And the tangent of 180 plus, oh, tangent goes positive here because negative y over negative x, tangent is positive in the third quadrant. So if you see the tangent of 180 plus theta, it's the tangent of theta. And here's just the summary of the things that I just said. Okay, the last quadrant and the fourth quadrant. If we went to 360 degrees, and then minus theta means bend clockwise out here. Here's where I'd be. I'd have exactly the same triangle as x and y, except y is negative. So I've reflected about the x-axis. But I get all the same trigonometric ratios, just the sign changes. So the sine of 360 minus theta is minus sine theta, because sine is negative down there. Sine is minus y over r. But the cosine's positive here in the fourth quadrant because x is positive. So 360 minus theta is just the cosine of theta. And the tangent of 360 minus theta, tangent's negative down there because it's minus y over x. And there's just a little summary of the things that I just said. Well, now you know if you just use all stations to Cape Town, if you see 180 degrees minus an angle, that means you're in the second quadrant. And so sine's the one that's positive, everything else negative. If you see 180 plus theta, you're in the third quadrant, and that means tangent's positive, everything else is negative. But if you see 360 minus theta, that means that cosine's positive and everything's negative. So that's a pretty useful thing. Now, sometimes I like to switch it. Instead of going 360 minus theta, they go theta minus 360. And if you went to an acute angle here at minus 360, you'd be in the first quadrant. And if you see theta minus 180, if you were at theta and then you bend it down minus 180 or go to minus 180 and plus theta, you're in the third quadrant. That's another possibility here. Well, that's our introduction, and I hope it helped. Okay.